300 teeth, arranged in spiraling rows, pointing backward. On the 21st of January 2007, a staff member at Awashima Marine Park in Shizuoka, Japan, noticed something wrong in the shallow coastal water near the facility. The morning air was cold and salt-sharp, the sea was grey, and something ancient was moving near the surface, slow and undulating and wrong. It measured 1.6 meters long, brownish grey, moving like an eel, not a shark. The body was serpentine with a single dorsal fin pushed so far back it looked like an afterthought. The mouth sat at the tip of the snout, not underneath like every modern shark you have ever seen, but forward, terminal, like a snake. Kazunori, Kubota, and the park staff documented it immediately. They filmed it, they measured it. The park released a statement that same week. We believe moving pictures of a live specimen are extremely rare. That was an understatement. Chlamydoselachus anguineus, first described by Samuel Garman in 1884, rarely seen alive, almost never filmed. Normally found between 500 and 1,500 meters down, in cold, lightless water, where pressure would crush an unprotected human body flat. This one had surfaced, which meant something was already wrong. Healthy frilled sharks do not come up. The 2007 specimen was almost certainly sick. It died hours after it was found. The exact cause was never documented in any peer-reviewed record. That gap still sits open in the literature, unresolved. But here is what Kubota recorded before it died. The gills slit 6 pairs, each one edged with a ruffled curtain, like fringe unlike anything on a living shark species today. The teeth, 300 of them, in 25 rows, each tooth a tiny 3-pronged trap built for squid, not flesh. A body plan that looked less like a shark, and more like something that had no reason to change. By the end of this video, you will know exactly what biologists found when they placed that 2007 specimen alongside fossil records, and why the comparison produced a term scientists use reluctantly. Because it implies something about evolution they still cannot fully explain. The simple explanation arrived within days of the 2007 footage. Scientists and journalists reached for the same word, relic. The frilled shark, they said, had simply never been pressured to change. Evolution works through selection, pressure, predators, competitors, environmental shifts. Remove the pressure, keep the animal. Straightforward, logical, case closed. Except the data refused to cooperate. Leonard Campagno, cataloguing frilled shark morphology for the South African Museum in 1984, documented something that should have been impossible. The jaw architecture, the precise angle of tooth implantation, the gill slit framing, the terminal mouth position matched fossil impressions from tens of millions of years earlier. Not close. Within measurable tolerance. 300 teeth, 25 rows, each tooth a 3-pronged hook, backward angled, designed to snare soft prey like squid without releasing it. Campagno measured them. Then he measured the fossil record. The numbers came back identical. That is not slow evolution, that is no evolution. The relic explanation starts to crack here. Slow evolution still means change, just gradual. A species under low pressure drifts slightly over geological time. Coloration shifts. Fin ratios adjust. Something moves. The frilled shark showed none of that. The 6-paired gill slits, fringed at the edges, a feature no modern shark species carries, sat in exactly the same anatomical position as fossil impressions from the late Cretaceous. David Ebert, reviewing frilled shark biology at Moss Landing Marine Laboratories in 2009, noted the species had survived conditions that collapsed most marine ecosystems entirely. 5 separate extinction events, ocean chemistry overhauls, temperature collapses that rewrote the deep-sea food web, and the shark changed nothing. Which forces a question the slow evolution model cannot answer. Evolution responds to pressure. 80 million years of catastrophic pressure produced zero measurable structural response. Either the model is wrong, or something about this animal operates by rules we have not written yet. Here is what Kubota and Sato actually found. In their 2008 paper published in Records of Awashima Marine Park, the two researchers compared the 21st of January 2007 specimen against late Cretaceous fossil records dating back 80 million years. The one filmed alive in shallow water off Shizuoka. Measurement by measurement, feature by feature, the comparison took time, the conclusion did not. Zero structural change, not one. The 300 backward-pointing teeth, arranged in 25 rows, tricuspid, designed to trap soft-bodied prey rather than tear flesh, identical to the fossil record. The 6 paired gill slits with their frilled, ruffled edges identical. The terminal mouth position, sitting at the very front of the head rather than underneath it, like every modern shark, identical. 80 million years of geological time, and the animal on the desk matched the animal in the drawer. 5 mass extinction events stood between those two specimens, the one that ended the non-avian dinosaurs, 4 others before it. The frilled shark crossed all 5 without biological pressure to change a single feature. The term biologists use for this is arrested evolution. They use it reluctantly. Here is why that word makes evolutionary biologists uncomfortable. Evolution does not pause, it responds. Pressure changes anatomy. Anatomy changes to survive. That is the mechanism. But Chlamydoselachus anguineus presents a direct challenge to that logic, not because it disproves evolution, but because it demands a question the data cannot yet answer. Not how did it survive? Why did it have no reason to change? David Ebert, at Moss Landing Marine Laboratories, noted that the frilled shark's deep water environment may have remained stable enough to remove selection pressure entirely. Cold, dark, consistent. A world that never asked anything different of the animal inside it. The 2007 specimen died hours after surfacing. The cause was never formally documented in peer-reviewed literature. A creature unchanged across 80 million years, and we still cannot explain why it came up at all. That question mark exists in a researcher's notebook somewhere, underlined, not erased. If you found this fascinating, subscribe. We investigate strange, real creatures like this every single day.